Hi guys, your Friendtor Gopika is here, and in this video we will discuss the practice set 3.1. That is the first practice set in your third chapter, circle. Okay, so all the theorems which are required in this for this particular practice set, and few solved examples, everything we discussed in the last two videos. I hope you watched those. If you have not watched, please check the playlist in the description box and do watch the previous videos or the introductory videos of the chapter, and then watch this particular video so that you get continuity in the topic. So without wasting time, let's get started. So this is the first question in the practice set. It says, so first let me choose the pointer. Now in the adjoining figure, the radius of a circle with center C is 6 centimeters. Okay, so this is the circle with center C and its radius is 6 centimeters of length. So line AB is tangent. So here you can see the diagram. Line AB is the tangent and A is the point of contact. So we will need to answer the following questions using this information. What is the measure of angle CAB and why? Why is it? Okay. So this measure angle CAB. So if you join the segment CA and then if you check, the CA is perpendicular to AB, since by tangent theorem radii is perpendicular to the tangent at the point of contact. So this angle CAB is 90 degrees. That is what the reason is. So first let's make the construction. So joining CA and then that is same as R radius. And then we will join CB also, because this we will require in the next questions. Okay. So first you do these two constructions, and then second part is what is the distance of point C from line AB. So distance of point C from line AB is same as CA. So that is what is the second question. Third is distance AB. So we need to find distance AB. No, distance AB is given as 6 centimeters. We need to find distance BC. Okay. And fourth part is we need to find measure of angle ABC. So this particular angle we need to find. Okay. So let's see the solution. Measure angle CAB is 90 degree. Why measure angle CAB is 90 degree? By tangent theorem. By tangent theorem, the tangent is perpendicular to the radius at point of contact. So CA is perpendicular to AB. That means angle CAB is 90 degrees. Second part, distance of point C from line AB is same as distance C comma A, and that is same as the radius. So that will be 6 centimeters. Third part is distance AB is 6 centimeters. We need to find distance BC. Okay. So AB is 6. Also CA is 6. We got from the second part. So AB is 6 and CA is 6. That means in this particular triangle we have CA is 6 centimeters, AB is 6 centimeters, and angle CAB is 90 degrees. That means here we can use the Pythagoras theorem in the triangle CAB, and hence hypotenuse which is BC. So BC square is equal to AC square plus AB square, and that is 6 square plus 6 square. 6 are 36. So 36 plus 36 will be 72. Now if you don't know what is Pythagoras theorem, or if you, I think you should know it because you are learning since 7th standard, but still if you want to know the proof of Pythagoras theorem, then do watch my videos on the chapter Pythagoras theorem. Okay, so you will get clarity of the concept. Now after this, BC we got to be, BC square is 72, means BC is square root of 72. Square root of 72 means 2 into 36, so that is 6 root 2 centimeters. That means BC is 6 root 2 centimeters. Okay. Now fourth part is we need to find measure of the angle ABC. So measure angle ABC we need to find. Now AB is 6, AC is also 6, BC is 6 root 2. So AB, AC, BC, if you find ratios of all three, you will get 6 is to 6 is to 6 root 2. And if you divide by 6 throughout, then that will be 1 is to 1 is to root 2. So this is the ratio. So if you see the ratio, that means you can say that the triangle ABC is a 45-45-90 degree triangle. By converse of 45-45-90 degree theorem. Okay. Now this converse says that whenever you have a triangle with its side in this ratio, then that triangle is a 45-45-90 degree triangle. this ratio 1 are the sides which is opposite to 45 degree angles, and root 2 is the side opposite to the 90 degree angle. Okay, so AB and AC is opposite to 45 degrees. That means measure angle ABC is 45 degree. Okay, simple, a very simple problem. The first part we are using tangent theorem, and next rest parts we are just using the general things that we already know. Okay, so let's move on to the second problem. So this is the second question. In the adjoining figure, O is the center of the circle. From point R, segment RM and RN are tangent segments touching the circle at MN. So here from an exterior point R, there are two tangent segments drawn, RM and RN, where M and another circles are where the circles are the points at which the tangents are touching the circles, and OR is also a segment and its length is 10 centimeters, joining point R and the center. Okay, now radius of the circle is 5 centimeters. Then we need to find length of each tangent segment. That means we need to find length of MR and length of NR. Also we need to find measure of angle MRO. Okay, so these are the first two parts. There are more two parts to the question, or one more part to the question that we will discuss in the next slide. So here in this particular thing we need to make two constructions. One is joining OM and then joining ON. So let's do that. Okay, so from the center we have joined the point of contact of two tangent segments RM and RN. Now this OM is perpendicular to MR and ON is perpendicular to NR by tangent theorem. Okay, so when we make the construction we notice that fact also. Now first we need to find what is the length of each tangent segment. So you consider one of the triangles. Here two triangles are formed. One is triangle OMR and triangle ONR. So considering one of them, in triangle OMR, angle OMR is 90 degrees by tangent theorem. So OM is perpendicular to MR by tangent theorem, and hence OMR is 90 degrees. Okay, so here I might be using directly I wrote the fact that it is 90 degrees, but you need to mention the tangent theorem and all those details over here. Okay, given part, to prove part, all those details you have to mention. Here in the videos I'll be discussing directly the solutions. Okay, so detailing you need to do it by yourself. So angle OMR is 90 degrees. That means by Pythagoras theorem OR square is equal to OM square plus MR square. OR square is the hypotenuse. OR is the hypotenuse. So OR square is OM square plus MR square. And OR value is given to be 10. So 10 square is equal to 5 square plus MR square. Now OM is 5 since OM is the radius. Okay. Now 10 square is 100, 5 square is 25. So MR square should be 100 minus 25, that is 75. So MR is square root 25, and that is 25 into 3. So 5 root 3 centimeters. Okay, so MR is 5 root 3 centimeters. Now by tangent segment theorem, what does tangent segment theorem says? Whenever from an exterior point, if you draw two tangent segments towards the circle, then those tangent segments are congruent. That means it's congruent to Rn, and hence Rn also will be 5 root 3 centimeters. So we found length of each tangent segment. That was the first part of the question. The second part is finding the measure of angle MRO. For that, in triangle OMR again, if you see OM, MR, OR, if you find the ratios of these three sides, then that should be 5 to the 5 root 3. 5 is to 5 root 3 is to 10. So again dividing by 5 throughout, it would be 1 is to root 3 is to 2. So this ratio, if you see, now this is ratio of a 30, 60, 90 degree triangle. So the side opposite to ratio 1 is 30 degrees, opposite to root 3 is 60 degrees, and opposite to 2 is 90 degrees. Okay. So MRO means it is angle opposite to MO, and hence it is the angle is 30 degree measure. Okay, because it is giving 1 in the ratio, one part in the ratios. Okay. Next, now this is the third part of the same question. We need to find measure of angle MRN. So here is the diagram, and same construction also we have done. Here MRO we found in the second part. Now we need MRN. For that, in triangle OMR and in triangle ONR, now these two triangles OMR and ONR, we will prove that these two triangles are congruent, and it is very simple. One is side OM is congruent to segment ON, since both are radii of same circle. Next, we have a common side to the triangles, that is OR. So segment OR is congruent to segment OR since they are common side. Now we know that RM is congruent to RN, or MR is congruent to NR, since these two are tangent segments, and by tangent segment theorem we know that from an exterior point, if you draw two tangent segments, then they are congruent. So by SSC test, we can say that triangle OMR and triangle ONR are congruent to each other. Now angle NRO is equal to angle MRO is 30 degrees. So angle NRO is equal to angle MRO is equal to 30 degrees, and that means angle MRN. Therefore, angle MRN is angle MRO plus angle NRO, and that is 60 degrees. So MRN measure we found. Okay. So let's move on to the next part. So this is the third question in the practice set. Here again we have something similar to the previous problem. There is one external point. From there we have two tangent segments RM and RN, and then the construction is already made. OM and ON is already joined, and hence we are getting two triangles. So segment RM and segment RN are tangent segments of a circle with center O. Prove that segment OR, now this segment OR bisects angle MRN and angle MON. That is what we need to prove. So just like we did the last part of the previous problem, we will prove that these two triangles, that is triangle MRO and triangle ONR or NRO, are congruent. So consider triangle OMR and triangle ONR. Here OM and ON are radii of the same circle, so those two segments are congruent. Next, segment MR is congruent to segment NR since they are by tangent segment theorem directly. Okay? One more fact we know, that this segment OR is common side. So that fact you can use, or else I have used another fact which we know, that angle OMR is congruent to angle ONR since both are 90 degree angles. By tangent theorem, ONR and ON 90 degree angles. Okay, so that fact also you can use, or you use the common side part, anything as you wish. So if you are using the common side part, then you will have three sides are congruent, three pair of corresponding sides are congruent. So there you will use SSS test. Now here I have used two sides and one pair of angles, so I am using SAS test. So by SAS test, triangle OMR is congruent to triangle ONR. Therefore, angle MRO is congruent to angle NRO since they are corresponding angles of congruent triangles. Similarly, MOR is congruent to angle NOR. Again, they are corresponding angles of congruent triangles, that is CACT. So we proved that these two angles are congruent. That means segment OR is bisecting angle MRN as well as angle MON. So let's see the next. Okay, so this is the fourth question in the practice set, and this is the last. So what is the distance between two parallel tangents of a circle having radius 4.5 centimeters? Justify your answer. So if you see the diagram, so this is a circle with center O, and these two lines segments are two parallel tangents. Okay, and A is the point of contact of tangent 1 and B is the point of contact of tangent 2. Okay, now we need to find the distance between these two parallel tangents. That means we need distance AB. Now distance AB should be distance AO plus distance OB. Since AO plus distance OB. Now AO is radius, OB is also radius. So that is 4.5 plus 4.5, and that is equal to 9 centimeters. Okay. So if you draw the diagram and show the then show the calculations, then that's enough justification. But one more thing we can mention over here. In this particular problem, we are using the fact that we saw in the second solved example, which we discussed in the previous video. Actually, just before starting the practice at 3.1, we did tangent segment theorem and we discussed few solved examples. In that, one of the examples we found this fact, this which I have written in words over here. Now this happens since segment joining point of contacts of two parallel tangents is the diameter of the circle. So whenever you have two parallel tangents, then the point of contacts, if you join, then that segment will pass through the center and is the diameter of the circle. Okay, since AB is the diameter and radius is 4.5, so distance AB should be 4.5 into 2, that is 9 centimeters. Okay, so that's the justification for this particular problem. So actually I'm done with the practice set 3.1. So go through the problems, and if you have any doubt, please write in the comment section. So thank you for listening to me, guys. If you have any doubts regarding the practice set, then please write in the comment section, and please like the video, share it with your friends, and please subscribe the channel. And you can also follow us on Instagram. If you have any doubts or queries regarding mathematics, you can directly DM Insta or just mention in the comment section. We will make a video or we will reply you as soon as possible on the particular topic. Thank you. Bye.